The unit analysis method is a very powerful technique for solving problems. It's also called dimensional analysis. I first learned this in physics class in high school, my junior year, which was longer ago than I care to admit. It was probably the most valuable and useful thing I learned in high school. I have used it a lot since then, and it's an awesome method. And so I'm going to teach this to you, and I'm going to try to force you to learn it. If you learn the unit analysis method, it will help you through most chemistry problems. You can't use it on all of them, but most of the problems in chemistry, stoichiometry and density things and all kinds of stuff, we can use unit analysis. It saves a lot of memorization, okay? And especially going into 1A, memorization of specific methods to solve specific problems doesn't work very well because the instructors are going to intentionally give you stuff you haven't seen before to see if you understand the concepts. If you understand the concepts, you can think on your feet and do the problem. Unit analysis will help you do that. So here are the basic steps. First, write down the unit that's asked for in the answer. We have to read through the problem and find out what unit are they wanting us to give. Then we need to identify and write down the given value. So there's a unit that they want, there's a number and a unit that you're starting with, and then you're going to apply a unit factor, sometimes more than one, that will help you get from the given value to the unit in the answer. So we'll do some examples. Use unit analysis to show how many seconds are in 3.55 minutes. So what unit do they want us to find? Seconds. The question, show many. Fabulous. First typo here. Show how many, I have to fix that. How many seconds? So seconds is what we're going for. And what do they give us? 3.55 minutes. 3.55 minutes. Do we know a relationship between minutes and seconds? Yes, we do. So that tells us we can go directly from minutes to seconds. So this is like a path that tells us where to go. And this is really important because you write that path out, the map, and then all you have to do is follow the map. Have any of you seen the TV show Dora the Explorer? Yeah, right? Well, who do we call when we don't know which way to go? The map. And the map comes out and says, well, if you want to get to the snowy mountains, first you have to go over the bridge and through the tunnel, and then you get to the snowy mountains. Question?
I think the first thing that he says is he announces that he's the map.
That's true. He says, I'm the map. And he sings a song, doesn't he? I'm the map, I'm the map, I'm the map, I'm the map, I'm the map. I have 6 children. I've heard that a lot. Thank you for the correction there. But then they chant the directions, right? I forgot my directions already. But we can chant this minutes to seconds. And it seems a little dumb here, but we're starting with something that's simple and obvious, and then we'll work up to more difficult things. This map tells you where to go, because sometimes you get into the middle of a problem and you get lost, right? You forget what you were doing, and you're like, wow, I have no idea. This is our map. We're taking minutes and we're converting them to seconds. And every time we have an arrow between units, we are going to have a unit factor that goes in there. So this is how we do it. Now that's our map, and now we're going to write the actual equation. We're going to write down the number and the unit that we're starting with. For every arrow, we're going to have times and a line, and then we'll get to equals. This one only has 1. The units in the map are the units that go in the numerator all the way across your equation. So minutes to seconds, minutes to seconds. So we write seconds in here. It's unit analysis because we're analyzing the units. We don't have to remember, should I multiply, should I divide? The units tell us what to do. So from our path, we've got minutes and seconds. We need minutes to go away. We want them to cancel out. So we take this unit and we put it in the denominator over here. Because what's minute divided by minute? It's 1, right? Units are like variables in algebra, they can cancel out. So the minutes are going to cancel out. And the unit we're going to end up with in our answer is seconds. Now we can't stop there. This has to be equal to 1. And so this one we can do in our heads, but sometimes you may want to actually write down that unit equation. 1 minute equals 60 seconds. So what unit is with seconds? 60. What number? Second is the unit. So 60 goes up here, and 1 goes down there. This is like the fraction line. And this side can be on the top with this on the bottom, or we can put this side on the top and that side on the bottom. Just think of tipping it sideways and making it into a fraction. And then we just do the math. And I forgot my real calculator, so I'll have to use my phone. It is fine to use your phone in lecture, but you do need to have a real actual calculator, and the phone should be just in a pinch because you need to learn how to use the real calculator. 3.55 times 60 gives us 213. And the unit, seconds. When you're first starting out, I want you to write the path, the map. When you get better at it, you can just write the equation part. But in the box there, that is the minimum I expect for showing your work. You need to learn how to show your work. They will expect you to show your work with units on everything in Chem 1A. I know this because I teach Chem 1A, okay, and I make my students do this. So learn how to write this out. Any questions about that one? You all could have done that yourselves. Let's do a metric conversion. What is the mass in grams of a 325 milligram aspirin tablet? There's another typo on that one. This should be hyphenated. Okay, what unit are they asking us for? Grams. And what quantity do they give us? 325 milligrams. These are nice, simple word problems. There's a minimum number of words. So here we have milligrams, and here we have grams. This is the base unit. I'm actually going to just rewrite it as G. Erase the rest of that. Just G. When we're doing metric conversions, look to see how many prefixes there are. Here's one prefix, and this one doesn't have a prefix. That means we can do this in one step. One prefix, one step. So we can go directly from milligrams to grams. So now we're going to follow our pattern. We're going to write down our given quantity with its units. We have one arrow, we have one unit factor. Milligrams to grams is what the map told Dora. Milligrams to grams, so down here, milligrams to grams. The unit from the previous term is what goes down here because we want this to cancel out, and the way to get rid of that is to divide by itself. If we divide by milligrams, the milligrams cancel out. Now we need to figure out the relationship between milligrams and grams. So we have to ask ourselves, what does milli mean? 10 to the what? -3. So there's milli. I'm going to write what it means on the other side of the line. And if you use this more simple method, you always do it that way. Milli from the table means 10 to the -3. I write milli on one side of the line, I write what it means on the other side. Now you might look at that 10 to the minus 3 and say, how do I put that into my calculator? If I multiply that by 1, does it change the value of anything? No. What does that look like now? Scientific notation. Do we know how to do that on our calculators? We should. So to do this then, we've got 325 times 1 EE, change sign 3. And we're going to end up with 0.325 grams. Any questions? If you're good with exponents, you can do calculations like this without your calculator. Because multiplying by 10 to the minus 3 means you need to move the decimal point to make the number smaller by 3 places. So I actually didn't do this on my calculator, I did it in my head. And that's another nice thing about metric units. You can convert them in your head if you understand powers of 10. Now, you are not required to understand powers of 10 and do them in your head. So feel free to use your calculator. What happens if we have 2 prefixes? If we have 2 prefixes, we're going to use 2 unit factors. This is not the only way to do it, but this is how I'm going to teach you because it's the most successful way. Here, it's more important to draw a map so you don't get lost, okay? Then if you do get lost, you can go look at the map and figure out where you are. So a hospital has 125 deciliters of blood plasma. What's the volume in milliliters? So again, we follow that, those steps. What unit are they asking for? Milliliters. So that's, I do that all the time. M, lowercase m, capital L. Bless you. And what quantity with unit am I given? 125 deciliters. So deci is a lowercase d and capital L. And we look at this unit. This one has a prefix, the one we're starting with. The one we're ending up with has a prefix also. We have 2 prefixes. We need 2 steps. We're going to have 2 unit factors. The one in the middle is going to be the unit without a prefix. So we're going to go from deciliters to liters, and from liters to milliliters. That guy was just like way too big, so I'm going to move him over. Okay? Doesn't matter what 2 prefixes there are, you can always do it this way. From the one with the 1 prefix to the base unit without a prefix, and then to the unit with the 2nd prefix. So here's our map. Let's do our equation. 125 deciliters. I have 2 arrows, so I need 2 unit factors. The map says deciliters to liters to milliliters. So down here I've got deciliters to liters to milliliters. I need deciliters to go away. So I'm going to divide by deciliters. You see what's happening here? This unit comes to the denominator over there. And then I'm going to put liters down here. This unit comes to the denominator over there. It's kind of a diagonal pattern here. Because now liters cancel, deciliters cancel. So our units are working out. We do the units first. The units tell us where to go. Now we go back and put in the numbers to make these fractions into unit factors, because 1 liter does not equal 1 deciliter. What does the prefix deci mean? It means 1/10. It definitely has to do with 10, but if we look it up on that table, deci equals 10 to the minus 1, which is the same as 0.1, which is the same as 1 over 10. But this is the guy that I like. So deci is in the denominator. I put what it means in the numerator, 10 to the minus 1. Over here, I've got milli in the numerator. I'm going to put what milli means in the denominator. Milli means 10 to the minus 3. I can follow this pattern, and if I don't remember which one's larger, I don't have to worry about it. The pattern works whether I remember which unit is larger or not. I have to memorize the metric prefixes, what they mean. Deci is 10 to the minus 1. And then I just plug them in here, and I do it on my calculator. Just remember, 10 to the minus third, you enter that as 1 times 10 to the minus third. And this you enter as 1 times 10 to the minus 1. If you know how to convert those into decimal notation in your head and you prefer to type them into your calculator that way, that's fine. So 125 deciliters times 1 times 10 to the minus 1 divided by 1 times 10 to the minus third. 1 EE minus 3. Plus 2. So this should be I'm doing it in my head, which is probably a bad idea, but if you like exponents, here we've got minus 1, and we're dividing by minus 3, so that's the same as adding plus 3, and minus 1 is plus 2. And so I'm actually multiplying by 100. The best way to write that answer would be in scientific notation to get rid of those ambiguous zeros, like that. Did anybody do it on their calculator and come up with the same answer? No, nobody did. Somebody did. Yes?
I just have a question.
Mm-hmm.
There's some problems in the book, and it has been for the 1,000 part per milliliters. I'm wondering why the same thing for liters.
That's the more advanced method, because a milliliter is 1/1000th of a liter, which means that there are 1,000 milliliters in 1 liter. And so they end up being the same. It's a different way of looking at it. And my experience is that the way the book is doing it, 1,000 milliliters equals 1 liter, is a lot of students have trouble with that. If it makes sense to you and you can do it and get the right answer consistently, by all means do it that way. That's fine. But doing this way, there's a set pattern, and if you follow the pattern, you'll never go wrong. It's a good question. Anybody else have any questions? Yes?
When we're doing this on test and we're showing the work, can we just multiply by tenths of a second, and go straight there? Will it make a difference next time?
If you're required to show your work, I would like to see this written out. If you want to do some mental math in doing the calculation, I am fine with that. But I would like to see the individual relationships. Now, is it possible to write a relationship between deciliters and milliliters and do this in one step?
Yes.
Yes, you definitely can. That is not a straightforward operation for most students, and so that's why I'm not going to teach that. Yes? If you showed the units and wrote it out, I would be fine with that. And so just in case you're curious, there are 100 deciliters, 100 milliliters in 1 deciliter. And so you could do 125 deciliters times 100 milliliters per deciliter and come up with the same answer. And this is perfectly acceptable showing your work. I'm just going to warn you, it's dangerous for many students. And you know who you are. If that works for you, by all means, okay? But I'm not recommending this to the class as a whole. Any other questions? So let's do a couple more. 4.29 kilograms to grams. So when questions are expressed this way, it's very straightforward what they're asking for, right? We're trying to get to grams, and we're starting with 4.29 kilograms. One prefix, one step. So 4.29 kilograms times a unit factor. Kilograms to grams, kilograms to grams. And then kilograms go down here because I want them to cancel out. Are you seeing that pattern? And then we need a number in here somewhere. We ask ourselves, what does kilo mean? 10 to the third. So kilos down here, I'm going to write what it means on the other side. 10 to the third. And if it helps you, write 1 times 10 to the third. So then we do the math, and we end up with 4.29 times 10 to the third in scientific notation. Any questions? Thank you. I did that to trick you. Brain fart. Any questions? Yes?
You always want the answer written in scientific notation.
Pardon me?
You always want the answer written in scientific notation.
Scientific notation in my book is never wrong. Okay, so if it doesn't specify, you could do either. Here I would recommend scientific notation because the alternative is 4,290. This is one of those ambiguous zeros, which we would like to avoid using. Okay, it would not be wrong. It would not be wrong. Any other questions? Let's do the next one. What unit do we need to go to? Megameters. You know, when they say a rock star is making mega bucks, they're actually using the metric system. Mega means a million. Megabucks is millions of bucks, millions of dollars. And we're starting with 7.624 times 10 to the third centimeters. This one has a prefix, that one has a prefix. So I recommend that you go to meters in between because it works. Sometimes when we take shortcuts, we get lost or we end up in the wrong place or bad things happen, right? And so it doesn't end up really being a shortcut after all. So every time I read The Tortoise and the Hare, the tortoise wins, right? So slow and steady wins the race. So I know this may seem slow to some of you, but we're going to get there. So we go to the base unit in between. So here's our work, 7.624 times 10 to the third centimeters, 2 arrows, 2 fractions. Dora says centimeters to meters to megameters. So we're going to write centimeters to meters to megameters. The previous unit becomes the denominator because we want to cancel out those units. And so meter comes down here. So the units cancel out. This middle term, we have centi on the bottom. We need to write what centi means on the top. Centi means 10 to the minus 2. So I'm going to put 10 to the minus 2 up here. Here we have mega on top. And mega means 10 to the 6. So I'm going to put 10 to the 6 down here. So you can do this on your calculator. 7.624 EE3 times 1 EE minus 2 divided by 1 EE6 equals. Or you can look at the exponents. Here we have an exponent of 3 When you multiply, you add exponents. And so 3 and minus 1 gives us an exponent of plus 1. When you divide, you subtract. So plus 1 minus 6 is minus 5. And so the answer comes out to be 7.624 times 10 to the minus 5 megameters. Somebody check me on their calculator. Okay, thanks. Any questions?
For the test, a lot of questions, be simple like this, or maybe next in the real world.
Some of them will be more complicated, definitely. Yeah. There's a little trick, not really a trick. It's always good to look at your answer and ask yourself, does it make sense? And you can apply something that I call the bigger, smaller rule for unit conversions. If we're looking at kilograms and grams, which unit is larger? Kilogram is bigger, right? So the larger unit, the bigger unit has the smaller number. The smaller unit has the bigger number. The most common, the easiest mistake to make is to get your number in the wrong place. And so you end up multiplying when you should divide or vice versa. When that happens, the size of the unit will change in the wrong direction, and the bigger, smaller rule will catch that. Here, a centimeter is smaller than a megameter, and so this should be the small unit with the big unit. Yes, small number with the big unit.
I was confused. The way I was reading that is how many megameters are in 7,624 centimeters?
Yes.
That's correct.
7.6 times 10 to the minus 5. Because a megameter is a million meters. And a centimeter is 1/100th of a meter. So this is a big unit. It has the small number. This is the small unit. It has the big number. Any other questions?